Hello everyone, my name is Anishana and you are watching Kubernetes web series. Today we are going to cover one interesting topic, that is what is deployment. So agenda of this video is what is deployment. In the previous video we learned that deployment replaces the replica set. What extra it is offering to us, we will explore it only. In this topic I'm not going to explain why we are using deployment, as I have already covered this question two times in replication controller and replica set topic video. Second topic is understand the fields in YAML file. Just for your information, a simple deployment YAML file is look like a replica set YAML file. However, in the deployment YAML file, we have more options as compared to replica set YAML file. Third is how to create deployment. There are two ways to create the deployment. I will explain it on this topic. Fourth is how to create YAML file for deployment. Good to know how to create deployment YAML file or from where we can copy the deployment YAML file. In fifth topic, how to check the deployment. kubectl describe option, I will explore it. In sixth topic, how to upgrade the deployment, rolling updates and rolling back. In seventh, how to rolling back to the previous revision. And in eighth, how to scale up the deployment. Under this, we will try to understand how to increase the identical pods. After that, how to delete the deployment. And in the 10th, use case of deployment. In the last, we will do lab and some exam preparations. So let's proceed for the first one. That is, what is deployment? A replica set is a Kubernetes object that runs multiple instances of a pod and ensure a certain number of pods are always running. If any pod goes down, then replica set will create a new pod. Deployment is a high level concept that not only create but also manage the replica sets. It provides declarative updates to pod along with many other features. Let's elaborate this point. A deployment is a resource object in Kubernetes that provides declarative updates to application. Now what is declarative? A Kubernetes object can create, updated, and deleted by storing multiple object configuration files in a directory and using kubectl apply to recursively create and update those objects as needed. In simple word, declarative means when we create a YAML file for any object, we actually declare the values. To explain more, in YAML file, we describe an application's lifecycle such as which image to use for the application, the number of ports there should be, and the way in which they should be updated. We instruct Kubernetes system through objects that how we want our cluster's workload to work. Bear in mind that deployment is a resource object. Deployment is a part of controller. We had already covered the controller function. Controller is a master component continuously check the desired state of objects which are created on the worker nodes through API server. Once the object created, our controller checks the desired and current state. Now we get to know that deployment manages the replica set. Therefore, all the features of replica sets are available in the deployment. Please note that as per the official recommendation, user should not directly work with replica set instead of using deployment. Next topic is understand the fields in YAML file. A simple YAML file is look like a replica set YAML file. It's time to elaborate the option. Type of object we want to create is kind equal to deployment. Name of the deployment is Nginx deployment. This deployment has its own label. Under spec section, we have replica. This option we use to instruct our deployment to create three identical pods. Under selector field, we have match label. Here we instruct this deployment to acquire the pods whose label equal to app nginx. In simple word, replica set will select the pods with this label. Under template section, we have again label fields. This label is for pods. When deployment create a pods, it add this label. In simple word, replica set will create the pod with this label. Please don't get confused here. Deployment will create a replica set and replica set will create the pods and add the labels. In global term, we generally say that deployment create the pods and add the labels. All works are being done by deployment. In the last, we have sections for containers. For more information about replication controller and then replica set, you may watch my videos. I have added the link in the description of this video. So now next topic is how to create deployment. There are two ways to create the deployment object. First one is from YAML file and the second one is from the command line. From the YAML file, we can use kubectl apply -f then YAML file name. You can also use create option instead of apply, no issues. From command line, again we will use kubectl create subcommand. Kubectl is a command, create is the subcommand, and please note that if we use command then it is always an imperative and for YAML file it is declarative. Deployment, type of the object that we want to create, nginx, name of the object that is name of our deployment on this particular case. In the last image, container will create from this image. Next topic is how to create YAML file for deployment. Again, there are two ways to create a YAML file for deployment. First one is manually and the second one is create a YAML file from command line. Let's explore the first one, that is create a YAML file manually. In order to create a YAML file manually, we have to create AKMS. I have already uploaded the detailed video to explain these features in replica set video, thus I'm not going to repeat this section again. This is our pod YAML file. If we keep aside this section only and rest of all the values move to deployment YAML file, we have the deployment YAML file ready. That's it. Very simple, very easy. Please bear in mind the indentation. That is the most important part. In this YAML file, we can segregate into different parts. First one is deployment. One can notice the indentation, API version, kind, metadata, and specs are on same place. Second section is for replica set. We should respect the indentation again. So replica, selector, and template should be on same indentation. Third section under the template is for pod. Under the template section, metadata and specs should be on the same indentation. Inside this pod further, we have container section. I hope you are now able to understand how to create a YAML file manually. If we have pod YAML file, we can also create a YAML file for the deployment from command line. So let's explore this option. Last time we used this command to create a deployment, right? This is the time we use this command again, but with extra option, that is -dry -run equal to client and -o YAML. When we use this option -dry run equal to client, kubectl will execute the command but not create the object. This option is only for the testing purpose. And -o YAML option is to print the output. -o equal to output. And the YAML is for YAML format. We will do it this on our lab. Next topic is how to check deployment. Now we have created a deployment and we want to explore what are the options inside this deployment. We can execute the command kubectl get deploy. Then it will show the output of all the deployments created on the default namespace. Please note that deploy is the short form of deployment. In our case, we have only one deployment created, so it will show you only one. When you inspect the deployment in your cluster, the following fields are displayed. Please note that the name and replicas are declared in the YAML file. Name lists the name of deployment in the default namespace. Ready display how many replicas of these applications are available to your user. It follows the pattern ready and desired. Up to date display the number of replicas that have been updated to achieve the desired state. Available display how many replicas of this application are available to your users. At the end, age display the amount of time since my application is running. We can execute the command kubectl get deployment nginx-deployment. Then it will show the output of nginx deployment only on the default namespace. We can execute this command with -n core option. Then it will show you the output of nginx deployment under core namespace if we create this deployment inside the core namespace. The output of both command would be same. We can execute the command kubectl get rs. Then it will show the output of the all replica sets created by deployment on the default namespace. Naming convention of replica set would be deployment -name and then hash. We can also check the pods and their labels by executing the command kubectl get pods --show labels. So this is the name. The naming convention of the pod is first we have the deployment name, second is hyphen, third is hash number of replica set, fourth is again hyphen, and then in the fifth field 5 alphanumeric characters. If you want more information, then you can execute the command kubectl describe option nginx deployment. Name of the deployment is nginx deployment. Namespace is default. This deployment has its own label, that is apps equal to nginx. Replica set which is managed by this deployment will acquire the pods who has the label app equal to nginx. Replica set will manage 3 pods. In the pod section, one can observe label is defined. It means that when pod created, this label will be attached. In the end, user can see the replica set name. Now, we will talk about how to upgrade the deployment. As of now, we understand that there is no option available to upgrade the replica set. However, we can upgrade the deployment binary. Let's understand with the help of 3D animation. We have deployment. Inside this deployment, we have replica set. Further, under this replica set, we have pods. And again, inside this pod, we have container running on it. If we want to upgrade the application which are running inside the container, we usually upgrade only container image. As of now, there is no upgrade option is available with replica set. Thus, when we upgrade the deployment, it create a new replica set with new image and remove the old replica and their pods. Further, if we want to roll back the change, it switch to old replica very simple in nature. A deployment's rollout is triggered if and only if the deployment spot template, that is specs.template, is changed. It means that when we want to upgrade the pod or its label, then only deployment upgrade will be happen. We can upgrade the deployment from the command line or by editing the deployment YAML file. Let's explore the command line first. Let's suppose we want to upgrade our existing deployment from image nginx 1.14.2 to nginx 1.16.1. Please note that we are going to upgrade the container image. Thus, we have to identify the container name first. For this reason, we can execute this command with -o YAML option. At the end, user can observe the container section. From there, one can see the container name. Now we have the container name and image name that we want to upgrade. The command would be kubectl set image. We want to upgrade the image. Then object type is deployment. Next is deployment name, that is nginx-deployment. Further, we mentioned that container name is nginx. In the last, we add the image name that we want to use. From the message, we get the confirmation that deployment image is updated. If we execute the command kubectl get pod, a new replica set is created and one can observe the name of replica set. Further, a new ports is also creating under the deployment. After some time, one pod will start terminating which belongs to old replica set. In this output, we can observe that one by one old pod get deleted and new pods up and running. It means that there will be no service impact when we upgrade the deployment. At the end, you will observe only 3 pods running under new replica set. If we execute the command kubectl get rs, we will observe 2 replica sets, old and new. How can we check? If we execute the command kubectl describe deployment and nginx deployment and grep 1.16, we will observe the image output, right? After that, if we execute the command kubectl rollout status, then we will see it is successfully rollout. It means that we have successfully upgraded the deployment. The third option we can use here, kubectl execute -it, it means that we are going to log in inside the container and then grep nginx. We'll observe in the environment variable that nginx version is 1.16.1. Last time we had different replica set, right? And now it is different. This time is 68 FC and the last time was 7 FP. Now we have completed the command line option. It's time to explore the option directly modify the deployment YAML file. Kubernetes offered us one command line option where we can directly modify the deployment YAML file. Let's go back to previous revision of this deployment where we had nginx 1.14.1. As of now, we have this replica set and it is showing 3 ports are ready. If I execute this command with option edit, then I can modify the container image to 1.14.1 and save it. I will show you in the lab. Again, if I execute the command kubectl get rs, we will observe our ports are now shifted to old replica set. Deployment binary are intelligent enough to understand with this image version I have already a replica set. So it switched to old replica set instead of creating a new one. Further, we can check the container image version by logging into the new container. Now you can see the new version is 1.14.1. Let's move to another topic. How to rolling back to a previous revision. In this topic, we will do the fallback, the previous upgrade. Let me execute the command kubectl get rs so that we can compare at the end of the result. In order to fallback the changes or rolling back to a previous version, one can use rollout undo option followed by object type and then object name. If we execute this command kubectl get pods -- show labels, one can notice old replica set pods terminating and a new replica set pods are created. And if I execute the command kubectl get rs hyphen hyphen show label, we will observe old replica set is showing ready in state. Next topic is how to scale up and down the deployment. In order to scale up the pods, we can use this command. One can notice there is a scale subcommand and we use hyphen hyphen replicas equal to 5. In the lab, first we will check the number of pods by executing this command. In the output, 3 pods are available. After that, we scale up the deployment to 5. It means that 5 identical ports are running and the output says scaled up successfully. If we execute the command again, then we can see that ports are scaled up to 5. Ready are 5 and up to date are 5. We can also use auto scale subcommand. If the CPU utilization of the ports are more than 70, then maximum number of ports can be created automatically up to 10 and the minimum is 5. In order to scale down the ports, then again we can use the subcommand option that is scale, but this time we take the replica equal to 2. From the message output, it is confirmed that deployment is scaled successfully. Same thing we can confirm by executing the command kubectl get deployment slash nginx hyphen deployment. And now only 2 ports are available and running. We can also scale up or down the port directly editing the deployment YAML file. When we execute this command, new file will be opened. From there, we can observe replicas equal to 2 is showing here. We just need to replace to 3 and save this file escape colon wq, and now we can see this output. Edit it. And if we execute this command kubectl get deployment, we will observe now 3 ports are running. So it means that we can also scale up or scale down from YAML file or from the command line. So we should know both ways. Now we will talk about how to delete the deployment. Before deleting the deployment, let's do the pre-checks. By running this command with hyphen hyphen show label, we get to know that our deployment name and how many ports are running under this deployment. How many replica sets this deployment is currently using. We get this answer if I execute this command. Here I use hyphen hyphen show labels, pipe grep, nginx. Because in the previous output, I know that my deployment has the label nginx. So there are 2 replica sets associated with this deployment. Let me give you one glance what we did so far. First time when we create this deployment, we had this replica set created. When we upgrade to 1.16.1 using set image option, a new replica set was created. We directly edit the YAML file of this deployment and switch back to 1.14.2. In that time, our deployment start using the old replica set instead of creating a new one. I had showed you one more option. If we want to fall back the changes, then we can use command option rollout undo. This is a sub command. Again, deployment start using 68FC replica set. Here you can see the naming color coding. 68FC, 68FC, 7FP, 7FP. Let me execute the command kubectl get pod with show labels. I can see 3 pods which are being acquired by this replica set. We have done the pre-checks and gather all the related informations. It's time to delete the deployment using delete subcommand. If I execute the previous command, I will see nothing. So deployment, there is no deployment. And if I use this nginx, obviously it will give me error. And what about the replica sets? All replica sets deleted. And if I execute this command pod, it is again deleted. So post checks completed and our activity marked successful. One obvious reason to use deployment is whenever we require to upgrade the replica set and roll back to an earlier deployment revision is possible in deployment. If we want to scale up or down the deployment, it means from 3 to 5 pods, we can achieve with the help of deployment and auto scale the deployment. As I said that it depends if the CPU is reached 60% or 90%, whatever you have said, it will auto increase the one new pod. So for these reasons, we can use the deployments. Let's jump to other next topic, that is lab plus exam preparation. So in the exam preparation, I will take CKA and CKAD questions to cover in the lab section.